Okay, so in the next part of the lesson, we are continuing the lesson on F3 integration. So next, what we are going to learn is we are going to learn to derive and use reduction formula. Okay, so this is one of the main parts of this book. The main part you always get one full question in the F3 paper for reduction formula. Okay, so first we'll see what is reduction formula and what it is used for. Okay, so basically now, for example, so they have said here, how to integrate, for example, sine square x, right? What is the technique that we use to integrate sine square x? We can use what? You remember we use cos double angle rules. So we can use cos double angle rule. We can use 1 minus cos 2x and we can find the sine square x integration. However, like the thing is, if you have like higher order powers of x, if you have sine to the power sine cube, sine to the power 5, like you can take really large powers of x, right? And then you can see the integration. If you go take it, it's not going to be simple. It's going to be really complex. So then we are going to use this reduction formula to help us to solve these, to help us to solve these values, to integrate. When you have these large values of n, how do we integrate? Because it's not going to be quite complex. So what we'll do is, best way to learn this is we'll do it through an example. We'll start with exercise 4. Let's start with exercise 4, question number 1. Look, so they have told you, first I will teach you how to understand what they have given here, how to read this. They have told you in, okay, in is equal to the integration of x to the power n e to the power x over 2. So you can see there are two functions here, x to the power n and e to the power x over 2. So this is what they have defined, the integral of x to the power n e to the power x over 2 is in. Okay, so then before I go to the integration part, let's discuss a few basic things. What is I1? If I ask you to define me I1, what is I1? Integration of x to the power 1 e to the power x over 2 with respect to x. So I1 means the integral. Okay, so it comes with the integral. So if I say I3, what do I mean by I3? Integral of x cubed times e to the power x over 2 dx. Now, when I take these I values here, I3, I4, can I get rid of the e to the power x over 2 even the power n is not there in this? No, this all, according to the definition that they have given you for in, it must, it needs to definitely look like this. Okay, it needs to have the x to the power along with the e to the power x over 2. Are you with me? So this is the basic reading of this equation. So let's see how we can integrate this. Okay, so what we do for the integration is we use what we can do here is mainly there are two techniques we use. The first technique that I'm going to teach you is we use parts by integration. Do you remember the parts by integration rule? Integration of u v dash with respect to x. What do we get? U v minus integration v u dash with respect to x. So this is the rule that I'm going to use. Okay, so then when you're using this, you remember in P4, you choose one person. U is the person that you choose to differentiate. V dash is the person that you choose to integrate. So here I will take, both options are available here. Now the thing is, now you can see x to the power n, I can differentiate. X to the power n, I can integrate. Isn't it? E to the power x over 2 also I can differentiate. E to the power x over 2, I can also integrate. However, now when both options are available, what I'll do here is, children, you can, I'll show you there's a very specific way to select here. The specific way to select here, you must choose your x to the power n as u. I will give you the reason for this in a moment, why we must select x to the power n as u. I think when I do the parts by integration and I'm trying to get this show that, do you see that they have given us a show that? My task is to get this show that. There is something called in here, do you see here in minus 1? In this show that, do you see in equal to x to the power n e x over 2? Shall I make it larger? The show that has 2x to the power n e to the power x over 2 minus 2n times in minus 1. Do you see in minus 1 here? Now I was telling you a moment ago how to write I1, how to write I2. So who is in minus 1? Just asking you. In minus 1 would be what? X to the power n minus 1 e to the power x over 2 dx. This is in minus 1. So then the thing is, I need to achieve in minus 1. Okay, I need to achieve in minus 1. So to achieve this in minus 1, you need to realize if you differentiate you take the power in front and you subtract 1 from the power, isn't it? Getting n minus 1. But if you integrate, what happens? We add 1 to the power and we divide, meaning I get n plus 1 power. So according to this show that, like looking at the show that, I decide because there's a I n minus 1, I need to create this, right? I n minus 1 means I need to create this, right? So to create this, I need to get this inside here. So to create this, we definitely need to choose our x to the power n as u. Do you understand why I chose it as u? So it depends on your show that. Basically, the UV, the selection process depends on the show that. So this is my v dash. So let's first write who are u and u dash. So if my u is x to the power n, what is u dash? Who is u dash? Differentiate, right? U to u dash. What is u dash? N x to the power n minus 1. Okay, then they have given us v dash is e to the power x over 2. Do you remember how to integrate? V dash to v is integration. Okay, so v dash to v, how do we integrate e to the power ax? Integration of e to the power ax is 1 over a e to the power ax, right? So basically here half x. So how does it come? 1 over, what's your a value? Half. 1 over half e to the power x over 2. That is, we can simplify it. 1 over half gives you 2 e to the power x over 2. So I have got my u dash and v dash and v. Okay, so u to u dash is a differentiation. V dash to v is a integration. Okay, now shall we input the values here? So I need to get in. In is the integration of x to the power n, e to the power x over 2 dx, right? Are you with me? So now I have already chosen what's going to be my u, v and v u dash. So input the values into this equation. Look at this. I'm going to input the values according to this order. Okay. So who is u? We have written here. I have written here all the things. Who is u? X to the power n. Into who is my v? Who is v? I have written here. 2 e to the power x over 2. So u v minus integration v. Who is v? 2 e to the power x over 2. So this is v u dash. Who is u dash? No, u dash is n x to the power n minus 1. Is okay? Okay, so basically I'm using this equation. I'm following the parts by integration rule. Okay, I have written everything over here. Now shall we rearrange this equation? So what do I get here? 2 times x to the power n e to the power x over 2. And then here, you can take anything that is not x. Now here the integration happens with respect to x. So we can take anything that is a constant, we can take it out. We can take the 2 and n now. So what do we get here? Minus 2n. I take 2n out, and what's remaining inside the bracket? X to the power n minus 1 e to the power x over 2 into dx. Do you see? Now who is this? Who is this person? Do you see? In minus 1 is integral. The integral of xn minus 1 ex over 2. It must come with the integration sign. No? Do you understand? So along with the integration, I have this full thing here. So this is what? In minus 1. In minus 1. This is equal to in. And is this to show that 2x, the in, to show that 2x to the power n ex over 2 minus 2n in minus 1. So for all n values greater than or equal 1. Do you see that we get this show that? So this is the starting. This is like a basic, very basic reduction formula. Okay, so one of the easiest to start off with. I hope you understood the parts by integration process. Is this clear? Okay. Then we'll go to part B also. Now here, this is where the practical use of this comes. Hence, find integration of x to the power 3 ex over 2. First of all, tell me who is integral of x to the power 3 ex over 2 according to this formula. Now, in is integral xn ex over 2. So this is integration of x to the power 3 ex over 2 must be definitely what? It should be I3, right? Okay. It should be I3, right? Are you all with me? So then basically what we do here is in part B, they ask you to find I3. So what is I3? I3 is integration of x to the power 3 ex over 2. Now, if you go do this manually, you will have to use parts by integration 3 to 4 times. To do this manually, it's very wrong. It's quite tough. Imagine if you have x to the power 5, a large x to the power would mean that you would have to do the, if you do the parts by integration manually, in the P form method, you would have to go really long. Okay, so then the practical use of this reduction formula is once you get a derived formula. Now, do you see reduction in the sense? Here you have in, here you have in minus 1. Do you see the I value decreases? Okay, the n value decreases here. So now what we do here is we'll find I3 here by using this equation that we derived. Okay, we'll find I3 by using the equation that we derived. Okay, tell me how to input the values here. I3 equals, tell me, 2x cube. Talk with me, e to the power x over 2 minus 2 into 3 is 6. I3 minus 1 means I2. Are you all with me? So I use this equation I3 and it reduced to I2. Now what do? We find the value of I2. How do I find I2? Go to the same equation. Go to this exact same equation and replace n with 2. Are you with me? Replace n with 2. So I'll come here 2x to the power 3 e to the power x over 2 minus 6 times I2 is. Okay, so again you go here. Are you all with me? You again come back to this equation. I2. What is I2? 2x to the power 2 e to the power x over 2. I'm following this equation here. Minus 2n I 2 minus 1, right? 2 minus 1 is I1. Are you with me? 2n, sorry, 2n means n is actually 2, right? So 2 into 2, that is a 4. So 4 I1. Are you all with me? Let's open this bracket. Let's open the bracket. What do we get here? 2x to the power 3 e to the power x over 2. This bracket opens with minus 6. Okay, are you with me? Okay, so then I get here minus 6 into 2 is how much? Minus 12 x square e to the power x over 2. Okay, and then minus 6 into minus is plus 6 times 4 is 24 I1. Are you with me? So we are not done yet because the thing is, if we go to find I1 here, is it easy to find I1 manually? No, I1 is x to the power 1 e x over. Still it has the x and e. So still there is a product. You know what? To find I1 also, what will I do? To find I1 also, what will I do? I'll use this equation again. I'll use this equation again. So how do I use it again? 2x to the power 3 e to the power x over 2. This part comes as it is, right? 12x square e to the power x over 2 plus 24 times the I1. Put a big bracket. Put a bracket. So go to I1. 2 x to the power 1. Input 1 here. Fine. 2x to the power 1 e to the power x over 2 minus 2 into 1 is 2 I 0. I naught. Okay, so now you might be wondering, so I have I naught. Are we going to put I n is 0 and are we going to continue? No, actually what we do is when we come to the smallest value that we can get, you can see here now, for example, I naught. I naught is something that we can easily find manual. Manual means you go to the equation here and find I naught. Is it difficult to find I naught? Look at here, what is I naught? Looking at this equation, in is x to the power n e x over to the integration. So I naught is integral of x to the power 0 e to the power x over. Do you think this requires part by integration? No, right? So I naught gives me what? X to the power 0 is 1. Basically, integration of directly e to the power x over 2. This integral is direct. So what do I get here for I naught? E x over 2 divided by half, because 1 over a. The a value is half. This half x here. A is half. So 1 over a e to the power ax. So 1 over half e to the power half x, which gives me how much? 2 e to the power x over 2 is your I naught. So can't you input that value here and get the final answer for I3? So 2x to the power 3 e to the power x over 2 minus 12x square e to the power x over 2 24 into 2, what do we get? 48 x e to the power x over 2. 48 into minus 2 is, sorry, 24 into minus 2 is minus 48 I naught, which is I naught is we found here. Let's input that here. 2 e to the power x over 2. And don't forget the plus c. So end of the day, this is our final answer. 2x to the power 3 e to the power x over 2 minus 12x square e to the power x over 2 plus 48x e to the power x over 2. 48 times 2 is 96 e to the power x over 2 plus c. Okay, so this is it. This is called reduction formula. And why is this important? The thing is, if you go do this x cube e x over 2 integration manually, you wouldn't be, I mean, even though this method looks long, you wouldn't be able to get the answer for this in such a short amount of time. You would have to do parts by integration over and over many times. It's a really long process. So the reduction formula, do you see why it's called reduction formula? Why is it reduction formula? Because when we start with I3, we go to I2, we go to I1, we go to I0. Basically, the I values are reducing. That's why it's called reduction formula, because we basically reduce, and we come to the I0, which we can easily find the answer. Are you with me? Okay, so this is the first question. So basically, all the questions we need to follow a similar kind of structure. Okay, so let's go for the next one. Okay, question number 2, they have told you IN equals integration. So it's a definite integration. 1 to e x times ln x to the power n dx, where n is the element of natural numbers. Okay, so basically it's the counting numbers you have for n only integers. Okay, right. So how do we go about integrating this? So once again, I think you realize when it comes to now reduction formula, obviously in reduction formula you can see the show that has a in minus 1. To have in minus 1, definitely this, what is in minus 1? So before I even start, let me write who is in minus 1. Who is in minus 1? Integration 1 to e x times ln x to the power. Who is in minus 1? The only difference here is the n is replaced by n minus 1. So this is in minus 1. Okay. Okay, so the only difference is it's now having n minus 1 power. So now what we need to do is we have to try to get our show that. So to get this show that, you can see we have the in minus 1, which means who will be your u, who will be your v dash. The ln x must be, now normally we go for x to be our u, right? But in this case, you can see anyway ln x is something that we know how to differentiate. So definitely in this case, instead of going for u with x, we'll go for u with ln x. Because then only the power will reduce. Because when you differentiate, the power subtracts by 1, isn't it? And then x will be your v dash. Do you agree with me? So let's try with that. So u is ln x to the power n. How do we differentiate ln x to the power n? U dash. How do I differentiate u to u dash? What's the rule? First thing is you give priority for the power when you're differentiating. So n comes from ln x to the power n minus 1. First you do the power. After you're done with the power, go inside. So ln x differentiation is, yeah, which is simply 1 over x. Ln x differentiation is simply 1 over x. This is u dash. If I write again, u dash is n times ln x to the power n minus 1 divided by x. Are you with me? Okay, then let's go for v dash to v. So v dash to v is integration. V dash is x. What will be v? You add 1 to the power and divide, because this is integration. Are you with me? Okay, then let's write down the integration. So in integration x times ln x to the power n. So what's the rule we use? uv minus vu dash, isn't it? The rule we use is uv minus integration vu dash. Okay, let's input the values. U. Who is u? Ln x to the power n. u v. V is x square over 2 minus integration v is x square over 2. U dash is n times ln x to the power n minus 1 over x with respect to x dx. Okay, now the thing is this. Do you see that this part, I mean, this particular part that I've taken, this UV, is outside the integration, right? It's not inside the integral sign, which means this particular part is already done with the integration, isn't it? Which means I can apply what? I can apply my integration limits here because this part is done with the integration. So we can apply our integration limits here. Let's apply the integration limits here. What do we get then? Ln e to the power n into e square over 2. This is the first limit minus the second limit ln x to the power 1 into x square over 2. Ln x holding power 1 into x square over 2. So this is basically when you input the two limits, e and 1. Are you agreeing with me? Did I do something? Oh, yeah, I had to put here. The x should be 1. Sorry. The x should be 1, not the n. Sorry, the x should be 1 here. The n stays, right? Ln 1 to the power n. We replace the x with e and then we replace the x with 1. So here also, I have replaced the x with 1. Okay, ln 1 to the power n into 1 square over 2. This is okay. The other part you can kind of rearrange, take all the constants out of the integral sign. Who are the constants? N and the half, the divide by 2, you can take it out. So what's remaining inside? X square is there and there's x here. Can't we cancel it out? The x square and the x we can cancel. What do we get then? X times ln x to the power n minus 1 into dx. Do you see this? Okay, now did I get my in minus 1? Because why? I mean, the rule is really strict. Basically, to get in minus 1, can I have any x square here or x cube here? No, I mean, you have to look exactly like this. You can't have any other x power here. So here, now do I have that exact same x power? Yes. Okay, so in an event, if I get here x cube or some other power, I cannot use in minus 1. Do you understand? It needs to look exactly like this. So this is, I have the exact in minus 1. Agreed? So then let's input the values here. Inside the big bracket, I get ln e is 1. So basically, I get 1 to the power n into e square over 2 minus, what about ln 1? Ln 1 is a 0. So basically, multiply anything with 0 is a 0. Close the bracket. Minus n over 2. So x ln x n minus 1 with respect to x, the integral. This integral is what we call as what? This is our I n minus 1. This is our I n minus 1. Okay, so let's simplify this a little bit. I n equals 1 to the power anything. I mean, 1 to the power n is 1. 1 to the power of anything is 1. So e square over 2 minus n over 2 times I n minus 1. Are you with me? Is it okay? Okay, so then part B, hence show that the integration of x ln x to the power, how much do we have? Part B, the integration of x ln x to the power 4. From 1 to e is e square minus 3 over 4. So we need to get this, show that. Okay, so then shall we get started? So x ln x to the power 4 means what I value are we talking about? I what? I4, because in is x ln x to the power n. If this power n becomes power 4, then we're talking about I4. Are you with me? So then we need to find I4. How do we find the value of I4? By using our the proven reduction formula. We use I4 here and we are trying to get our answer. Are you with me? So let's go for I4. Part B, we need to find I4. So how do we find I4? Replace the e value to e square over 2 minus, tell me the n is 4 now, right? So 4 divided by 2 into what? I. 4 minus 1 is I3. Are you with me? Continue. E square over 2 minus 4 over 2 is 2, right? Let's write as 2. And 2 times I3. Replace the I3 value. Who is I3? I3 is e square over 2 minus 3 over 2 times I. See here I3. I put it to here. I3 is e square over 2. Replace n with 3. minus 3 over 2 I. 3 minus 1 gives you what? I2. Do you see the way I replaced? So before you go to replace again for I2, just open up the bracket. Otherwise, it gets more complicated. So I get here e square over 2 minus 2 into e square over 2 gives you what? 2 and 2 will cancel. E square minus 2 into minus 3 over 2 gives you plus 3 I2. Is that correct? I think we can add e square over 2 minus 1 e square minus half, half minus 1 is minus half. Plus 3 times I2. Who is I2? Go back to the equation. I2. Go back to this equation here. Replace the n with 2. So I2 equals what? E square over 2 minus I2 means 2 divided by 2, right? I what? I1. Okay, so is it easy to get I1 directly? If I go for I1 here, I get XL and X. No, there's again still a product here for I1. So we'll go for I0. Keep using the rule. First, we'll open the bracket minus half e square. 3 into e square over 2 gives us what? 3 e square over 2. 3 into minus 2 over 2 means 2 over 2, it cancels. It's just 1. So I get here minus 3 I1. Do you agree with me? Do you agree with me? Okay, then let's replace I1. Before I replace, can you all add these values? Minus half e square plus 3 over 2 e square gives you 1 e square. Or just e square, simply e square. Minus 3 times I1. Replace I1. Go to this equation and replace the n with 1. So make sure you put a bracket because after 3 multiply by I1 value, which gives you e square over 2 minus replacing the n with 1 over 2 I0. Do you agree with me? E square minus 3 over 2 e square minus into minus is plus 3 over 2 I0. So 1 e square minus 3 over 2 e square gives me what? Minus half. Plus 3 over 2 I0. Shall we find I0 manually? Go to the equation. We will find I0 manually. So who is I0? Integration of x, ln x to the power 0. N is 0. N is 0. So x ln x to the power 0. And your limits are from 1 to e. So let's input the value of ln x. Any ln x to the power 0. Basically, any number to the power of 0 gives you 1. So I end up getting here integration of x with respect to x. The limits are from 1 to e. So what do we get here? When we integrate x square over 2 and make sure you give your integral limits from where to where? From 1 to 2. So when we give this, we get 2 square over 2 minus 1 square. 1 to e. Sorry. 1 to e. 1 to e. So it's e square over 2 minus 1 square over 2. So basically it's e square over 2 minus half. So input the value here. This is 3 over 2 times I0 value is e square over 2 minus half. Open the bracket. Minus half e square. 3 over 2 into e square over 2 is 3 over 4 e square. 3 over 2 into minus half is minus 3 over 4. Do you agree with my working? Minus half plus 3 over 4 gives me 1 over 4 e square minus 3 over 4. So basically 4 is common, right? So it gives me e square minus 3 over 4, which is the show that. This was our show that. Okay. Question number 5. So they have told you here the in is equal to the integral of tan x to the power n. As the in is equal to the integral of tan x to the power n. And then they have told you by writing tan x to the power n, as tan x to the power n minus 2 into tan square x. Do you understand how they have broken it here, right? So tan to the power n minus 2 into tan square, when you multiply, it gives tan to the power nx. Do you understand? So basically, say you have a to the power n, can't you break it as a to the power n minus 2 times a to the power 2? Because same base powers, when they multiply, the powers are added. So n minus 2 and 2, when you add, you get a to the power n. So that rule is what they are using here. Power n, they are breaking it as power n minus 2 into power 2. So basically, when you multiply the same base powers, the powers are added and you get power n again. Do you understand? Okay, so then they are saying here, and then they ask you to show that by using, they ask you to use this formula and then show that for n values greater than or equal to, that you get this particular, show that in equal in minus 2 minus 1 over n minus 1. Okay, we get something like this. Shall we work on it? It's 6 marks. Okay, so first things first, let's write down our equation. Who is our in? It's tan x, tan to the power nx. So they have told us, the question starters itself, they've told us to break it. So tan n minus 2x into tan square x. So basically, why are they telling us to do like this? Maybe we can use parts by integration, like for some reason like that. But when you try to use parts by integration here, now do you see, first of all, we have tan square x. Okay, so this is a person. Now I'm trying to see whether now normally when there's a power with some person, the n, I think of like maybe I should differentiate that person, because already in the earlier question, the people with the power n were differentiated. Did you see that? And the other person was integrated. So if you look at tan square here, do we know how to, now this the other person should be the one who is normally integrated. So do we know how to integrate tan square? Do I have integration? These are the integration rules, right? I have given them here. Do we know how to integrate tan square? No, right? We don't know how to integrate sec square. So what is the relationship we use? We have the equation, the trigonometric equation was 1 plus tan square is sec square. Hyperbolic equation is 1 minus tan square equals sec square. Are you with me? 1 minus tan square sec square. Do you agree? Which means 1 minus sec square x is equal to tan square x. So integration of tan to the power n minus 2x, tan square x is 1 minus sec square x. Do you see my replacement? How I replace tan square x? I replace it as 1 minus sec square. So now let's open the bracket, tan to the power n minus 2 into, let's open it. So I end up getting here tan to the power n minus 2x. Is that okay? Minus sec square x times tan to the power n minus 2x. Is this okay? Is this okay? Are you agreeing with my working? So now let me input the integral sign. Integration tan to the power n minus 2x minus integration of sec square x tan x to the power, shall I just put it like this, tan x to the power n minus 2 with respect to x. All of these are with respect to x. Are you with me? So now look what I have created. Now we all know tan x, in is equal to tan to the power n, right? So what is this? What do I have here? Integration of tan to the power n minus 2. Do you see it looks like very similar? The integral sign in is defined for tan to the power nx. So now what do I have here? Tan to the power n minus 2. So then what do you think? Who is this? Who is this person? This is n minus 2. Do you understand that? See, if you have n minus 2, you have integration tan n minus 2, right? Power n minus 2 x. That's what you have, right? Then this is in minus 2. Do you agree with me? Then how do we do the integration of our next part? So this is where it gets tough. This is where the parts where this reduction formula gets difficult because you need to learn to think about these things. Now the other one, what about sec square x tan x power n minus 2? In this one, what rule can I use to integrate this? We can use the rule f dash x, fx to the power n. So this is my fx. So what is the, now you know the power is irrelevant here, right? You need to write the f dash x. What's the differentiation of tan x? Tan x differentiation is given here, right? Here, tan x differentiation, d by dx of tan x is sec square. Do you see I have my f dash x here perfectly? Do I need to input anything here? No. So then f dash x fx to the power n, what's the integration? Fx to the power n plus 1 over n plus 1. So tan x n minus 2, you have to add 1, right? Are you with me? For n minus 2, we add 1. Okay, do you agree with me? And have they put a plan? Just go with the show that they have given. Look at the show that. So we get here I n minus 2 minus, what do I get here? Tan to the power n minus 1x, right? Over n minus 1. Did I get the show that? In equal in minus 2 minus 1 over n minus 1. Basically, this n minus 1, same thing. They've written it as 1 over n minus 1. Do you see? So that's our show that. So 6 marks for this. Next part, they are asking me to find the integration of tan to the power 5x. So find tan to the power 5x. So tan to the power 5x is actually what? This is I5. I5. So I5 equals, input the value here. What do we get here? I5 equals 5 minus 2 is I3. 1 over 5 minus 1 is 4. And x to the power 5 minus 1 is 4x. Look at what I've done here. I replaced the n with 5. It's not, you should not copy paste. You should try to understand what I'm writing here. Like go to the equation, replace each and every single n value with 5 here. Okay? Are we done here? Now then let's go for I3. So how do we go for I3? I5 equal, because I'm trying to find I5. Go for I3, replace I3. So now replace the n with 3. What do you get here? I3 minus 1 is I1 minus 1 over 3 minus 1 is 1, right? Sorry, 3 minus 1 is 2, sorry. 3 minus 1 is 2 into tan. 3 minus 1 is 2, tan square x. Are you with me? So do you think I should go for I think you can see if I go to the if I go to put I1 here, we get I negative 1. Sorry, we are not done here. After we input the I3 value here, we should also write what? This part, right? This remaining part should be written here. Minus 1 over 4 tan to the power 4x. Because these two are what we wrote for I3. After I3, we have to continue. Minus 1 over 4 tan to the power 4x. Then I1, do you think I need to use the reduction formula again? No, because if you go for I1, I get here 1 minus 2, I get I minus 1. So don't go for negative. So basically, in this case, we can't go for I naught. So we can stop at I1. So who is I1? So you know In is tan to the power nx, right? So I1 is equal to simply integration of tan x. Okay, so integration of tan x is given, right? Here, integration of tan x is ln cos x. Integration of tan x is ln cos x. Do you agree? So then input the values here now. So what do we get here? I1 is equal to ln cos x, right? minus half tan square x minus 1 over 4 tan to the power 4x. So this is I5. Do you understand how I5 works? Okay. And then you can put a plus c at the very end. After you integrate at the end, you can put a plus c because there are no limits here. Since there are no integration limits. Is this clear? Part C, show that the integration of tan x to the power 4 dx. However, in this one, in part C, the difference between part B and C is in part C, they have given you clearly what? Integration limits. They have clearly given you integration limits. So let's input those limits and get the answer. Integration of tan to the power 4x from 0 to ln2. So let's try this. Part C. I'll do it over here. The integration of tan x to the power 4 from 0 to ln2. So basically, tan x to the power 4 means what? What are we finding now? Tan x to the power 4 means we are working with which I4. So let's go. Let's work with I4. So we didn't find I4 in the previous part, did we? No, right? We were going with I5, and this is since it's going with n minus 2 reduction powers. We went from I5 to I3 to I1. Okay. So let's go here. I4. So input the value of I4. I4 equals, use the equation here. This is our main equation. Do you see? This is the main equation. I4 equals, what is it? I2 minus 1 over 4 minus 1 is 3. Tan 4 minus 1. Tan cube x. Do you agree with me? So I4 equal I2 minus 1 over 3 times tan cube x. Then the next one we have is, we are not done with it. We need to replace I2 now. So let's replace I2. Who is I2? I2 equals, actually I2 is something you could go further. I mean, since you can see here, I2 is something, no, we have tan square x, right? The tan square is not something that we can directly integrate. Or else, if you all can see, I2 is tan square x. And you all actually can use the set square equation to integrate that if you all want. However, otherwise you can use this equation again. Yeah. So let's go for I0. So I2 equals to what? Go back to this equation. I2 equals what? I'm replacing the I2 value here only. I2 equals I0 minus 1 over 2 minus 1 is 1. Tan to the power 2 minus 1 is 1, right? Tan x. That's just I2. And then don't forget the remaining part. What's the remaining part? Minus this term. 1 over 3 tan cube x. Don't forget that person. Okay. Then I0, I think now it's a lot easier to find, right? So I0 will be what? I0 will be integration tan x to the power 0. What happens when you have any number to the power of 0? It's 1. So basically you integrate 1. What happens when you integrate 1? You just get x. And you see it's a lot easier with I0. So I0 is simply x minus tan x minus 1 over 3 tan cube x. And then at the end, now we don't need to put plus c here. Why? Now we're done with integration because there are what? The integration limits. What are the limits? After you're done with the integration, let's put the limits. 0 to ln2. Let's input the values. X is ln2 minus tan ln2 minus 1 over 3 tan cube ln2. Are you with me? We need to get a show that, right? Minus, replace with 0. 0 minus tan 0 minus 1 over 3 tan cube 0. So let's input the values. Input it one by one. ln2 tan ln2. What's the answer? I think you can type it in the calc and it will give you the direct answer because you have it in terms of e to the power 3 over 5 tan ln2. You can type tangential into in the cal, or else you can use the equations e to the power 2x minus 1 over e to the power 2x plus 1. Okay, so it comes directly minus 1 over 3 tang cube L into tangential into we found, right? Tangential into is 3 over 5. So tang cube means it's 3 over 5 to the power 3. Are you with me? Minus 1 over 3 into 3 over 5 to the power 3. The reason being because it's a tang cube L into. Tangential into is 3 over 5. Cube of that is power 3. Zero is 0. Tang 0 is? Tang 0 is 0, which means tang cube 0 is also 0. Basically, the whole bracket is a 0. Am I correct? Simplify. And now simplify this. What do we get? 3 over 5 minus 1 over 3 into 1 over 3 times 27 over 125. Final answer?
Yeah.
So we should get the show that. Are we getting the show that? Minus 84, 125. Basically means you type this in the cal. When you type it in the cal, do we get this answer? Minus 3 over 5 minus in the middle. Yeah, not minus 3 over 5 minus 1 over 3 into 27 over 125. Check the answer. See whether it comes. Okay, so we get this answer, right? When you type in the cal, we get ln2 minus 84 over 125. Okay, let's move on to the next question. Question number 7. Let's try question number 7. Given that in equals, question number 7. Given that in equals to the integration of ln x to the power n, ln x to the power n with respect to x, and your limits are 1 to a where a is greater than 1 and it's a constant. Show that for n value is greater than or equal 1, in. The reduction formula is in equals a times ln a to the power n minus n in minus 1. Okay, how do we get this show that? Now you can see it's a 8 mark show that. Okay, so basically now you need to kind of like break this up. Like we can use product rule or some in the earlier question. You saw how I split the tangents, right? The way we split it. Okay. So in this question, what do you think is the most effective way to get this done? Do you think splitting this will help, like ln x to the power n minus 1 into ln x to the power 1? Okay, then what is the most effective way of getting this done? This is something you learn in P4. The technique that we are using in this sum is something that you do to integrate ln x in P4. You can't take any x or n out. I mean, you can't take this n front as a power, by the way. Now, we all know normally for ln x, we take the, I mean, if you have ln x and if your x has a power n, then the n can come out. Then the n comes out as n times ln x. But here, this power n is not for the x. It's there for the whole ln x function. So therefore, this time the power n doesn't come out. Are you with me? So now what do we do? This case is different. This case is different. Do you understand? The two cases are completely different. So what do we do here? What's the technique we use? The technique we use here is we use parts by integration, and in P4 what did we use? We use the 1 here. Look at this. 1 is going to be our V dash. Are you looking at this? 1 is going to be V dash. ln x to the power n is going to be your U. Just look at it. U is ln x to the power n, right? So what will be your U dash when you differentiate? N times ln x to the power n minus 1. First finish off the power, then go inside. Ln x differentiation is 1 over x. So basically U dash is n times ln x to the power n minus 1 over x. Then the next one is V dash. V dash is 1, which means V is integration of 1 with respect to x is x. Okay, integration of 1 with respect to x is x. Okay, then let's input the value. In equals uv minus integration v u dash, right? So who is u? Ln x to the power n, u, v is x uv minus integration v u dash is n times ln x to the power n minus 1 over x. Are you with me? So I get here in equals x times ln x to the power n. I think we had integration limits here, right? So then to the part that is done with the integration, you can apply the integration limits, which are from 1 to a. You can apply the limits because you're done with the integration. In the other section, what's going on? The x and x will cancel out, right? And we can take n out. And I end up getting inside the integral ln x to the power n minus 1. Okay, so now let's input our limits. So input a times ln a to the power n minus 1 into ln 1 to the power n. Do you see? Minus n times the other one. What about who is integration of ln x to the power n minus 1? So you can see in is ln x to the power n integration. So ln x to the power n minus 1 according to this format. When you have power n minus 1 on top here with the integral sign, it means it's I n minus 1 here. You see? Integral this part over here. The only difference is the n minus 1. So this is I n minus 1. There's an n in front. Are you with me? So then I get here I n equals a times ln a to the power n. ln 1 will be 0. So that is it. And then here I get minus n times I n minus 1. So 8 marks show that. Did we get the show that? Yes. Here I n equal a ln a to the power n minus n times I n minus 1. We got to show that. Do you see? Next, move on to part B. Find the exact value for the integration from 1 to 2 for ln x to the power 3. So what do you think is happening here? From 1 to 2. Now you know this in was the integral from 1 to a, right? The integral was from 1 to a. Now it's from 1 to 2. So what does that tell you? The previous integral was from 1 to a. We got our answer in terms of a. Now it's 1 to 2. So what's so your a value is equal to 2 and who else? This is what? I3, right? This is I3 where a value is 2. So let's get I3. Okay, are you with me? Let's input the answers. I'll put a equals 2 at the end. After a moment, after we are done with everything, shall I put the a value or shall I put it at the very beginning? Okay, no, what we'll do is we'll write the in equation in terms of a equal to. Okay, so what is the in equation when a equal to? We get here 2 times ln 2 to the power n minus n times in minus 1. I replace the a with 2 first because it's from 1 to 2. Previous one was from 1 to a. That's why the question came in, answer came in terms of a. So now a is 2, so 2 times ln 2 to the power n. Okay, now shall we find I3? Because now the limits are applied, right? So I3 equal 2 times ln 2 to the power 3 minus 3 times 3 minus 1 is 2. Do you agree with me? Continue. I3 equal 2 times ln 2 to the power 3 minus 3 times. Who is I2? 2 ln 2 to the power 2. I'm continuing with I2 here, replacing n with 2. 2 ln n to the power 2 minus 2 times I. 2 minus 1 is I1. Do you agree with my working? That's correct, right? 2 ln 2 to the power 2 minus 2 into I2. 2 minus 1 is 1. So I get here 2 times ln 2 whole into the power 3. Can I take this power 3 in front and multiply with the 2? This 3? No, it belongs to the whole ln 2. It's not belonging just to the 2. I was just testing you. You cannot bring this 3 in front. Open the bracket here. 3 into 2 you get 6 ln 2 whole thing to the power 2 minus 3 into minus 2 is plus 6 I1. Do you understand? Okay, then for I1, what can we do? Is it easy to get I1? No, right? I think we'll go for I0. We'll go until I0. So going until I0, 2 ln 2 to the power 3 minus 6 ln 2 to the power 2 plus 6 times I1. I1, go to this equation, replace n with 1. 2 times ln 2 to the power 1 minus replacing n with 1 here, 1 times I0. Are you with me? Get the I0 value. Who is I0? So our IN was integration from 1 to 2 ln x. Okay. Okay, so we get this. So I0 will be what? I0 will give you what? I0 will be integral ln x to the power 0, which gives you 1. So when you integrate 1, we get x, and our limits are from 1 to 2, right? So I get here 2 minus 1. Answer is simply 1. I0 is simply 1. So input the final answers. 2 times ln 2 to the power 3 minus 6 times ln 2 to the power 2. Here 6 into 2 is 12 ln 2. 6 I0. I0 is 1. So I get here. That's it, right? So 6 into 1 is 6. So that is basically 6. We don't need to put plus c here. Why? Because we have already used our integration limits. This year I have used the integration limit. So this is my answer. Okay. Part C. The next one, they ask you to show that the integration of ln x to the power 6 from 1 to e with respect to x is 5 times 53 minus 144. So now in this question, what's the a value? Now you can see in we got to show that the phi n in terms of a. So here when it's from 1 to e, obviously here the a should be replaced by e. Are you with me? So the first step in here is in part C, we write in. What's the in equation? Since it's from 1 to e, first rewrite the equation for in. So what's the in equation? In equals, instead of writing a, we write e ln e to the power n minus n times in minus 1. Are you with me? Who is ln e? Log base e is 1, right? Ln e, ln e is 1. Logarithm of e. So e 1 to the power n is 1. 1 to the power of anything is 1. So minus n times in minus 1. This in. Okay, is that okay? So now let's go for, let's get the values of I1. So we need to get what? I6, right? So I6, let's work on this. I6 equals E minus 6, I6 minus 1 is 5. Input, I6 equals E minus 6 into I5 is, replace again inside here. E minus 5I4. So you understand what I did here? Replacing the n with 5. E minus 5 by 4. First we'll open the bracket. E minus 6E minus 6 into minus 5 is plus 30I4. Do you agree? So E minus 6 is minus 5V. Agreed? Plus 30 times I4. Replace I4. Who is I4? Who is I4? I4 equals E minus I4. Replace n with 4. 4I3. So open the bracket up. Minus 5V. 30 into E is plus 30. 30 into minus 4 is minus 120 I3. So minus 5V plus 30 is 25V minus 120 I3. Replace I3 again. I3 is again E. Replace here. N is 3. E minus 3I2. You see? Open the bracket again. 25e minus 120e minus 120 into minus 3 is plus 360 I2. 25e minus 120 is 25e minus 120 is minus 95e plus 360 I2. Who is I2? Going back. E minus n is 2 for I2. 2 I2 minus 1 is 1. Do you see? So replace back again. Open the bracket. Minus 95e. 360 into e is plus 360e. 360 into minus 2 is minus 720. It's minus, right? Minus 720 I1. Is this okay? Check on the work and see whether you got until the same point as I did. Minus 95e plus 360 is 265. 265e minus 720. Let's replace I1. Okay, so I1 is, yeah, we're going to I0, right? It's easy to go. We can stop at I1 also, but no, I think going I0 is the best option because it's easy to integrate with the power 0. So I1 gives us, for the equation, replace n with in with 1. E minus 1 times I0. Do you agree with me? So I get here 265e minus 720e minus 720 into minus is plus 720 I0. Let's get I0. So who is our I0? I0 is integration of In is integration from 1 to e. Ln x to the power n. So when it's I0, what happens? Integration 1 to e ln x to the power 0. So any number to the power of 0 is 1. Basically integration of 1 with respect to x. Integration of 1 with respect to x is x. Limits are 1 to e. So I get e minus 1 for I0. Now what do you need to do here? Go and replace the I0 with I0 with e minus 1. So 265. Can I have the answer here? 265e minus 720 is minus 455e. Open the bracket here. Plus 720e minus 720. When we open this bracket, so then we get how much? 265e minus 720. Do we have a show that here? Divide by 5. 720, right? Correct, right? Okay, then take 5 out. Not e, there's no e. Yeah, just 720. Taking 5 out, 265 divided by 5 is 53 is 720 divided by 5 is 1. So is that our show that? Yes. So to get this in one go, you need a lot of practice, because in the exam, if you get a show that in this similar manner, to get to this show that, you need to be really good in your simplification. You must be able to open the brackets expertly. Okay. And get the answer. Okay. Okay. Let's do question number 9. Given that In, do question number 9, In is equal to sine to the power 2nx divided by cos x with respect to x. Write down a similar expression for In plus 1. Okay, so how do we write a similar expression for In plus 1? In plus 1 equals to sine. So you replace the n here with what? N plus 1. So 2 times n plus 1 over cos x. Okay, so then In plus 1 equals integration sine 2x plus 2, sine to the power 2x plus 2 over cos x. Do you agree? So they have told us to write down a similar expression for in plus 1 and hence show that in minus in plus 1 is equal to this. Okay, so what are we supposed to do? We are supposed to take in subtracting with what? In plus 1. So in is given to us. In plus 1 also we just found out right now. So then take those two and we'll subtract. So in minus in plus 1. In is integration of sine to the power 2nx over cos x. Subtracting with in plus 1 is sine to the power 2x plus 2, 2n plus 2, sorry. Over cos x. Right, so we can take the integration sign, both of them are integrated with respect to x, so I can take it out. And you can see cos x is a common denominator for both, right? So we can take cos x as a common denominator and we get sine to the power 2nx minus sine to the power 2n plus 2x. The integration happens with respect to x. This is okay? And now what we can do here is, how do we simplify this further? You can see that 2n plus 2, we can break it, right? How do we break it? Sine to the power 2nx. Now, if you have some number to the power n plus 2, we can write it as what? So, a to the power n plus 2 can be written as a to the power n and a to the power 2. A to the power n into a to the power 2. So, sine to the power 2n plus 2 also we can write as sine to the power 2nx into sine square x over cos x with respect to x. Yeah, now we can take sine to the power 2n out, not out of the integral sign, but just outside as common. And I end up getting 1 minus sine square x and divide by cos x. Who is 1 minus sine square? 1 minus sine square is cos square. I end up getting integration of sine to the power 2nx times cos x divided by cos x. Cos square x, yeah, sorry, this is cos square x. So 1 cos x to 1 cos x cancels. So cos x times sine to the power 2nx. How do we integrate this? So what rule do we use here? Yeah, we can use f dash x over fx, because basically here sine x is our fx. Sine differentiation is directly cos, right? So we have directly the f dash x, the rule f dash x fx to the power n, the reverse product rule. So this rule fx to the power n plus 1 over n plus 1. This is the rule, right? So we can use this rule immediately. So what do we get for the integration? Sine x to the power 2n plus 1 so this is it. We can write this as sine okay, so this is what in minus in plus 1, right? This is the answer we get for that. Do you see we get to show that? Okay, then let's move to the next part. In the next part, they say, use your reduction, write down similar expression. Okay, we wrote this for 6 marks. Find sine to the power 4x over cos x dx and hence show that, okay, they have given you limits and you have to get this show that. Okay, so sine to the power 4x over cos x. What do you think about sine to the power 4? Sine to the power 4x over cos x. So looking at this, what's the n value we should use? Look properly. Now look, what's the n value you should, now you have here in your show that, look at this properly. Your show that, this is the show that we got, right? Okay. Sorry, not that. Actually, that's the show that we need to look at this. Sorry, we need to look at this because this is the integration sign, right? This is the final answer. So I want to get the integration of sine to the power 4x over cos x. So this is the integration, the rule. In equals integration of sine to the power 2nx over cos x. So what's the n value here to get sine to the power 4? N must be equal to 2. Do you get it? So n must be equal to 2. So let's get it down there. Use n as. So I brought it down here. Now look. So once again, you always saying to me, we should use I2 here, right? So I2 will give us sine to the power 2 times 2, 4x, sine to the power 4x over cos x. However, now thing is, you have to get this show that obviously we will definitely be using the show that the proof we did in part A. But in part A, if we go to use I2, n as 2, do you see you get I2 minus I3 here? And I3 is, this gives me sine 2 times 3 sine to the power 6x. Do we really need something like that? No. So then to get the part B, show that, think a little bit strategically. What do you think I will use for my n value? What do you think I will use for my n value? Instead of using 2, let's use n as 1. What happens when you use n as 1? I get here I1 minus I2. I mean, I want to end up getting I2, right? I1 minus I2 equals sine to the power 2n plus 1 x over 2n plus 1. Do you agree? Let's input the I1 and I2 values. I2 is what we are trying to find. Find I1. Then I1 minus I2 is equal to this. So basically, I want to find I2, right? Because this equation is I2. So the only thing that's missing here is I1. Let's get I1. Use the first equation. I1 is integration sine to the power sine square x over cos x, right? This is what we get for I1. Or else what we can do is we can actually get I1 from the reduction formula again. That would be easier, right? Is it? Yeah, because there's a big integration here. If you want to find I1, we'll replace n with what? Oh, n with 0. When you replace n with 0, we get I0 minus I1 equals sine to the power n is 0. So sine to the power 1x over n is 0. So over 1. Do you see I replace all the n's with zeros. So I can get I0 minus I1. Then n is 0. Here sine to the power 1x over 2 times 0 is 0 plus 1. So I0 is what I'm, I0 I think we can easily find, right? Who is I0? Integration of sine to the power 0x over cos x. So integration of 1 over cos x, which is integration of sec x. So this is given in your formula book. Integration of sec x is given in your formula book. Check the book and tell me. Integration of sec x is given. Check the formula book in the P3 or in the P4 section. It's there. Check there. It's given. ln. It's there. It's in the yes, ln sec x plus tan x. This is in the P4 section, right? In the P4 section, integration part. Integration sec x is given ln sec x plus tan x. Do you see I0? Okay, so I0 is there. Now we can find I1 from here. Are you with me? So I0 is ln sec x plus tan x. And then what I'll do is I'll bring the sin x and take the I1 to the other side. Are you okay with that? Minus sin x equals to I1. Is that okay? Okay, so I1 is found. Now can't we can input that here and find I2. Actually in here when n is 2, I have to, so here I used n equal 1, right? So I1 minus I1 plus 1 is I2 sine. I have replaced n with 1 here, right? What do we get here when n is 1? 2 into 1 is 2. 2 plus 1 is sine cube x over 3. Do you agree? So input the value here. I2. So I'll take this here and I'll take this here. I1 minus sine cube x over 3 equals to I2. So I1 is found as ln sec x plus tan x minus sin x. That is I1. So basically what I did here was I substituted I1 and then minus there is a equals to I2. So this is what we need to find. This is I2. Do you agree with me? Okay. Then in the same question they ask us to put the limits here. Sine to the power 4 is over cos x. The limits are from 0 to pi over 4. So let's input the limits. So the limits are given. So in the next part, the limits are from 0 to pi over 4. Ln sec pi over 4 plus tan pi over 4 minus sine pi over 4 minus 1 over 3 times sine cube pi over 4. Compulsory minus, replace everyone with 0, the x values. Ln sec 0 plus tan 0 minus sine 0 minus sine cube 0 over 3. Okay, so type each and every value individually and let's get the answer. We need to get the show that. So I get here ln sec pi over 4 is 1 over cos pi over 4, which is root 2. Tan pi over 4 is 1, right? Sine pi over 4 is root 2 over 2. Is that okay? 1 over 3 sine pi over 4, the cube of it, what do we get? The cube of root 2 over 2. How much is it? Root 2 over 4. Okay, there's 1 over 3 outside. I kept it there. The other bracket, ln 1 over cos 0. Cos 0 is 1. Tan 0 is 0. Sine 0 is 0. Sine cube 0 is also a 0. So I end up getting here ln root 2 plus 1. Type this in the cal, minus root 2 over 2 minus root 2 over 12. Minus half minus 1 over 12. What do we get? Minus half minus 1 over 12. Minus 7 root 2 over 12. And from the other bracket, I get ln 1. ln 1 is 0. So I end up getting ln root 2 plus 1 over 7 root 2 divided by 12. Okay, is this to show that? Yeah, ln 1 plus root 2 or root 2 plus 1 minus 7 root 2 over 12. This is the exact show that we need to get. Do you understand? Yeah. Okay, question number 10. They have told you, we'll discuss question number 10. They have told you, given that in is equal to integration of x 1 minus x cube to the power n dx. Okay, so this is in. They are asking you to show that in equals 3n over 3n plus 2 into in minus 1. So you can definitely see here the I is reducing, right? N becomes n minus 1. So what do we do here? So what do we do here? Basically, I think you can see here, can we go for f dash x fx to the power n by any chance? No, right? Because sometimes, if you can go for f dash x fx to the power n, but that will not work here because you have x cube. X cube differentiation is 3x square. I have x here, so x square is not there. There's no way that f dash x fx to the power n will work. So what we'll do here is, I will go for the traditional parts by integration. So definitely the person with the power n, becomes the n minus 1, that must be the u. And this must be a v dash. So I get here u equals 1 minus x cubed to the power n. So when I take u dash, differentiating n times 1 minus x cubed to the power n minus 1. First priority for the power. After you're done with it, chain rule, go inside. Differentiation of 1 is 0. Minus x cubed differentiation is minus 3x square. So if I arrange it, I get here minus 3n times 1 minus x cubed to the power n minus 1 into x square. And the other one is our v dash. V dash is x, which means v becomes x square over 2. Okay. Then let's put it into our equation. In equals. So let's write the equation uv minus integration vu dash. Okay. So who is u? U power n u b x square over 2 u v minus integration sign v is x square over 2 v into u dash, which is minus 3n times 1 minus x cubed to the power n minus 1 times x square. Do you agree with me? Okay. Now the thing is this integration has limits, which means what? To the part that you are done with integration, just input your limits. Definitely put the limits. So limits are from 0 to 1. So when we input the limit 1, what do we get here? 1 minus 1 cube to the power n. 1 square over 2 minus, when you put 0, 1 minus 0 cube to the power n into 0 square over 2. I think you can see what's going to happen in each part. In each part here, 1 minus 1 is a 0. Here, 0 multiplied by whatever it is. These are both going to be zeros. Because here you get 1 minus 1, 0 multiplied with this is 0. Here 0, this multiplied with whatever you have here is a 0. So I end up getting here, let's take the let's take the figures out, the constants out. Minus 3n can come out. So with this minus, it becomes plus 3n, and there is over 2. Integration x square is x to the power 4, 1 minus x cubed to the power n minus 1 into dx. So we come to this point, and then it looks like, okay, now what's the next step? Are we going to do integration by parts again? What do we do? What's our next step? Okay, so this is why integration, this reduction formula is a little bit tough, and you require a little bit of practice to do this. So to do this, there's a small trick. Actually, in this question, they have given you a hint. After integrating by parts, write x to the power 4 as, look at what they have given. Write x to the power 4 as what? Now these hints are not given in the exam, okay? They have told you to write x to the power 4 as x times 1 minus x cubed. So why do you think they're asking us to do something like this? First of all, is this x to the power 4, is this expansion correct? Okay, you get here x times here 1 minus 1 plus x cubed, right? When I open with the negative sign, minus 1 plus x cubed. 1 and minus 1 cancels, and you get x into x to the power 3 is x to the power 4. Do you agree? Okay. So they are asking you to write it in this manner. They are asking you to replace x to the power 4 by using this particular format. X times 1 minus into 1 minus x cubed. So let's do that, what they are asking us to do. So in equals, this part is completely 0, plus 3n over 2, integration of x times 1 minus x cubed into 1 minus x cubed to the power n minus 1. Are you all with me? Okay. Then the next step, what's our next step? Our next step is to, I think you can see our now I'm going to create this in. I'm going to create in minus 1. The show that had in minus 1, right? So you can see in minus 1. If I write here, in minus 1 would be x times integration 1 minus x cubed to the power n minus 1, right? So it's not just 1 minus x cubed to the power n minus 1. There's x in front as well. So do you see here, now shall I don't want to rearrange the bracket and waste time, but I'm going to open this bracket by using these two together. Like basically there's a bracket here, and I'm going to open this bracket by using the x and the 1 minus x cubed to the power n minus 1. Do you get what I'm trying to do? Okay, both of them get together and expand this bracket. Shall we expand the bracket? I get here in equal 3n over 2, and when I expand integration, when I expand the bracket, I get x into 1 is x, and that into 1 minus x cubed to the power n minus 1. Do you agree with my working? I'll put a big curly bracket on top here. We'll put the curly bracket over here. The integration is there. I'm just opening with the x and this guy. Okay. The next person that I'm doing is I'm going to open the x, and I'm going to take this with these two. So x times minus is there. I hope you all understand this minus sign is what comes here. So x into 1 minus x cube into 1 minus x cube to the power n minus 1. Do you see what's going on here? Check again, this x multiplies with 1 minus x cube and the 1 minus x cube to the power n minus 1 multiplies with the 1 minus x cube. Yeah. So basically I end up creating here in equals 3n over 2. Let's include the integration sign separated to each part. Integration of x 1 minus x cube to the power n minus 1 with respect to x minus integration of x 1 minus x cube into 1 minus x cube n minus 1 is what? The powers add. I get 1 minus x cube to the power n with respect to x. So do you see what I have created over here? What have I created over here? I have x1 minus x cube to the power n is in. x1 minus x cube to the power n minus 1 is in minus 1. Do you see I have created both of those guys here? So I get here in equals 3n over 2. Okay. So after coming to this point, what do we see here? The integration. So inside the curly bracket, I have integration x 1 minus x cube to the power n minus 1 is our in minus 1. Do you see this is our in minus 1. So basically, this is my n minus 1 minus this is integration of x 1 minus x cube to the power n is in. So let's open this here. In equals 3n over 2 times in minus 1. 3n over 2 into minus in is minus 3n over 2 times in. Do you agree? So then what you can now the show that has in subjected, right? In the show that they've made in the subject. Can you see? In the show that they've made in the subject. So let's take all the terms with in to one side. I'll take the terms with in to one side. I get here in plus 3n over 2 in equals 3n over 2 into in minus 1. Take in out and I get here 1 plus 3n over 2, right? So 1 plus 3n over 2 is, you have to take the common denominator here, right? So taking the common denominator, I get 2 plus 3n. So I get here 2 plus 3n over 2 equals 3n over 2 in minus 1. Do you agree? So I end up getting here in equals to, 3n over 2 into 2 over 2 plus 3n. Basically, I took these two to the other side. In minus 1. The 2 and 2 cancels. And I think we can show that, right? 3n over 2 plus 3n in minus 1. This is our show that, right? I think this was our show that. This was our show that. Then they asked me to use our reduction formula to evaluate I4. So let's use the reduction formula to evaluate I4. Part B, how do we get I4? Replace n with 4, right? 3 times 4 over 2 plus 3 into 4. 4 minus 1 is I3. I with me, so I get here 3 times 4, 12. 3 times 4, 12 plus 2 is 14. So 12 over 14 is 6 over 7 I3. Is that okay? So come back over here and let's replace the I3 now. 6 over 7 times. Who is I3? 3 into 3 over 2 plus 3 into 3, right? I3 minus 1 is I2. So 6 over 7, 3 into 3 is 9 over 3 into 3, 9, 10, 11. I think this doesn't cancel out, right? So we get 6 times 9, 54 over 77 I2. And we get next one is we will go with I2. 54 over 77 I2. Replace n with 2. Replace. Go back to this equation. Replace n with 2. I get here 3 times 2 over 2 plus 3 times 2. I2. 2 minus 1 is I1. Are you all with me? So can I have the answer that we get at this point? Final answer? Yeah, how much? 81 over 154 I1. Is it easier to work with I1 or should we go to I0? I0 is a lot easier. Let's go with I0. So let's go with I0. So going on with I4 equal 81 over 154. I1 is what? So if you go to I1, it's 3 into 1, 3. You go to this equation and find I1, right? I1, 3 into 1, 3 over 2 plus 3 into 1. I0. So how much is this value here? 81 into 3 divided by 154 into 5. How much? 243 over 770. I0. Now let's get I0. Are you with me? Let's get the I0 value. How do we get the I0 value? So go to the main equation and find I0. So I0 is equal to integration x1 minus x to the power 0. From 0 to 1. So this is x1 minus x to the power 0 is basically 1. So you just get integration of x. So when you integrate x, what do we get? X square over 2. The limits are from 0 to 1. So we get here 1 square over 2 minus 0. So the answer is half. So I0 is half. Take back this answer over here. So I0 is half. So I4 equals 243 over 770. I0 is half. How much is I4? 1,540. So this is your I4. So you see how the difficulty and do you see the amount of working you need to do to get this done? Okay.